topic of level is partition coefficient. So by definitions, partition coefficient is a process of distributions of compound between two immiscible solvents. So meaning we have two solvents which immiscible solve with each other. Usually we have a organic solvent which is really which is non-polar, and then we have another layer of water. So CCl4 is non-polar because we have a net dipole, right? So meaning they have the same electronegativity value. So it makes this molecule is power to get the bond pair between C and Cl here. Okay, so whenever we have found this kind of compound, then this one will be polar, right? So non-polar cannot be dissolved in polar. Water is actually a polar molecule because basically you have a dipole negative of oxygen and dipole positive of arrow is pointing outward like this, and then the other arrow pointing to one direction. So meaning if you see this kind of direction, then you'll have a polar molecule, right? So polar cannot be dissolved in non-polar. So whenever we have this partition, it's like layer that separate the non-polar and polar, then you have a KPC later. Yeah, so it's actually partition coefficient. Okay, now if we see here, partition coefficient is actually equilibrium, right? It is equilibrium constant representing the distributions of solute between two immiscible solvent. All right, and then the symbol for partition coefficient is KPC. Okay, so for example, I have a chocolate look like this. All right, so and then for example, I have a, let me write, this one is a different color. So this is actually let's say I have a solution X. So I have a solution X. Here I have a solution X. Okay. And then the solution X I dissolve in ether. So it's actually in ether. All right, and then I have another layer. Okay, so here, for example, I have another layer. So this layer is actually layer for solution X, for example, in water. Solution X in water. So meaning I have two solutions, which is ether, right? Ether and water. Ether and water immiscible, right? They cannot dissolve each other. So and then afterwards I have a solution X, and then I put solution X here. Okay, so the solution X can be distributed in ether solvent, and then also solution X can be located here in the water. So later we'll determine how much the solution X can be dissolved in ether and how much amount of the solution X which can be dissolved in water, right? So if I use a diagram, maybe I can show you this one. All right, so for example, I have a solution X. So here, so let's say solution X, okay, located on the top layer. It is actually and then I have also solution X, which is located in the lower layer. So this is actually molecule of X. Okay, so if you say that this is actually ether and this is actually water, okay, the way you interpret this diagram is actually meaning the solution X is more soluble in ether compared to in water. Okay, all right. Now, having said that, if we use the equation again, I just mentioned to you, this is actually the equilibrium constant. All right, so the equilibrium constant of partition coefficient is Kpc, right? Kpc for this reaction is actually concentration of X in ether, all right, divided by concentration of X in water. So the reason why I got this is actually because of the equilibrium between X, okay, aqueous. Please note this actually reversible reaction. So I have ether. So if you have this equilibrium, all right, so if you have this one between the solution X in ether and solution X in water, then you'll have a the rate reaction of like this one. Okay, so it's actually the amount of X which distributed in ether solvent, and also X which distributed in water layer. Okay, so Kpc for this fraction is actually X is in ether divided by X in water. Now, if we study, if we study the example given in question number 1, so we can see here, it says that when a solution of X is actually 1 gram of X in 100 cm cube of water was shaken with 10 cm cube of ether, then we have a 0.8 grams of X transferred to ether layer. Now we are to calculate the partition coefficient of X between ether and water. So first and foremost, what you need to do is actually we need to find the mass of X. Okay, it says actually mass of X in ether. All right, this is actually 0.8. All right, so with assumption that total amount of X in the the two layers, which is ether and water, is 100 gram or 1 gram. So meaning I can calculate mass of X in water. Okay, so it is actually 1 minus 0.8, which is 0.2 grams. Okay, all right, so that's the first thing. So we need to find mass of X in ether and in water. The next step that we need to do is actually define the concentration. Concentration. So the concentration is actually for X in ether is actually 0.8 divided by, so what's the volume? So it's actually was taken in 10 cm cube of ether, all right? So divided by 10, okay? So this is actually gram, this is cm cube, then you will have a 0.08 gram per cm cube, right? So also I can calculate the concentration of X in water. So it is actually 0.2 grams divided by volume of water is actually 100. So divided by 100 cm cube, then I will have a 0.002 grams per cm cube. All right, so you might ask me why the unit of the concentration is gram per cm cube. It actually doesn't really matter, right? The unit for concentration can be gram per cm cube or mole per dm cube, right? But it's actually tells us that how much amount of something in amount of specific amount of volume is actually the concentration. So it can be in the form of gram or it can be in the form of also mole, right? So therefore, I can calculate the Kpc using this formula. So this formula, so Kpc is actually X in ether. So X in ether is actually 0.08. So 0.08 gram per cm cube divided by 0.002 gram per cm cube. Then I can cancel this. So it will give me 40. All right. Okay. Next is actually, let me clear up the window, so this screen, so it will be easier for me to explain the second questions. All right, so in the second questions, X has partition coefficient of 8 and between the solvent of hexane and water. Okay, so if a 25 cm cube of sample of water containing 0.050 grams of X is shaken with 25 cm cube of hexane, you are to calculate mass of X. All right, so for this one, you can actually write the X of um, aqueous, right? Goes to X of hexane. All right. So remember, hexane is actually C6H14, meaning this one is actually non-polar. All right. So this is actually non-polar molecule, while water, okay, is actually polar molecule. So they cannot dissolve each other. So if you see this equation, so the Kpc will be concentration of X in hexane, right? Hexane divided by concentration of X in water, right? So the value of Kpc is given already here is 8, all right? And then the concentration of X in hexane. So look at this one. It says that we have a X is shaken in 25 cm cube sample of hexane. So it's actually X divided by 25. All right. Therefore, you can actually calculate the mass of a water. Okay, if a 25 cm cube of sample of water containing 0.05 grams of X, so meaning that the amount of X which distributed in the water layer will be 0.005 minus X. All right, and then what's the volume? 25 divided by 25. Then if you do this calculation correctly, then you'll have the value of X will be 0.0044. All right. So meaning X is the value of X in hexane will be this one. All right, grams. How about amount of X in water? So in water will be 1 minus 0.0044 equal to 0.0006 grams. All right. So the thing is, you have to know, or how you have to be able to write the equation for the forward and backward reaction, and then you plot Kpc, and then you find that concentration is actually mass over volume, right? And then you can do calculation, then you can get the answer. Okay, I hope you enjoyed the learning today, and thank you for watching.